Okay, so we're going to continue with this polynomial, and we're going to have to do a few more questions about the remainder theorem before we go, before going into that thing that we call the factor theorem. Okay, so I want you to copy this question, and then we'll do this together and see what happens. Okay, so we're going to call this question 2 because this is a continuation of something that we did before. All right. Okay, so we're going to say use the remainder theorem to find the remainder when the first polynomial is divided by the second one. Again, then we have this polynomial. The first one is x cubed plus 5x squared minus 10x minus 4, and we're going to divide that by x plus 2. And the next one is x to the power of 4 minus 2x cubed plus 5x plus 2, and we're going to divide that by x minus 2. Okay, so we're going to have these two polynomials, and we're going to do this using the remainder theorem, but then we're going to double check the answer by doing the long division, and then I'm going to show you how we do the synthetic division. Okay? Right. Okay, synthetic division is really good, but is easier to use it when you are dividing by things like this. Okay, so if you divide by a linear polynomial is good, but if you are going to divide by a quadratic polynomial, then the synthetic division get very, very messy. You still can do it, but it's too complicated. So it's easier if you do it the other way. All right, so we're going to say solution. All right, for the first one. Okay, so because we are going to use the remainder theorem, we know that the answer for the remainder is going to be just -2 evaluated in that expression. So I'm going to say let p of x, so you're going to put this in polynomial form. So what we want then is to find the remainder, and we know that if you want to find the remainder, all what you have to do is to find p of -2. Okay, which means that you're going to evaluate -2 into that polynomial. So if you do that very carefully in your calculator, sometimes you can do it in your head. Okay, and then you're going to write the answer.
What's the answer?
Anyone?
What's the answer?
Wait, 5 times -2 squared, is that just positive 20? Or negative?
Maybe not. Is it 18?
Anything is square is positive. Okay, anything is square is positive. So I mean that this is going to be positive 20. So
28.
what is the answer?
28.
28. All right, 28. Okay, so that is the remainder when using, the remainder theorem. Okay, and you can see that that will save you a lot of time, especially in tests. But you've got to be aware at the same time in tests we're going to explicitly ask you to do the long division. All right, so you won't get away from doing long division. You have to do it. Okay, so what we are going to do now, even that the question doesn't say so, we are going to double check. Okay, we are going to double check and see if the answer is correct by doing the long division. Okay, also we're going to say, let's do the division. So we're going to put x cubed plus 5x squared minus 10x minus 4. And we're going to divide that by x plus 2. Right, let's do the long division, and then we're going to do the synthetic division. All right, so here we go. Okay, so you know that you have to multiply x by x squared, so then you get x cubed. Okay, so we're going to put x squared. Okay, and then we're going to do what we have been doing all the time. Okay, so you multiply x squared by x is x cubed, and then when you multiply x squared by 2, then you have 2x squared, and then we do the subtraction, so then we're going to have 3x squared, and then we bring the next number down, which is negative 10x, or the next term down, and then we do the same thing. Okay, so we need to now multiply by 3x, so we're going to put 3x on top, and then we do 3x multiplied by x, will give you 3x squared, and so on. Okay, so you're going to continue with this. Then the next one is 4. Okay, and the answer is 28 again. All right, so you can see that this is consistent with the long division. Now, I'm going to show you how you do the synthetic division, and it works like this. We're going to say, or okay, so we're going to do the same question using synthetic division. How you do it is actually very simple. Okay, so step number 1, you're going to look at the coefficient of the original polynomial, okay, the dividend, and you're going to write it down. So the first coefficient is 1, and the second one is 5, and then you have minus 10, and then you have minus 4, all right? So all what I did is just copy down the coefficient 1, 5, negative 10, and negative 4, right? Okay, and then somewhere here you can put the opposite to this number, so we're going to put negative 2. Okay, so we put negative 2. All right? And then what you're going to do, you're going to draw a line, and you're going to leave some space in here. And then you bring the first coefficient down, so you're going to put the first coefficient down there. And then we're going to do this. So we're going to multiply negative 2 times 1, it's just negative 2, so you're going to put it in here. And then we're going to perform this operation, so it's going to be 3. Okay? And then we're going to multiply negative 2 times 3 is negative 6, so we're going to put the negative 6 in here. Okay, so we're going to add these 2, so it's going to be negative 16. All right? And then we're going to multiply negative 2 multiplied by negative 6 is, what is it? Positive 32. All right? Positive 32. Okay? And then, well, the answer for this is going to be 28. Okay, so the last number will always give you, the remainder. All right, so you can find the remainder that way. But the other good thing about this is that in here, have a look. Here we have 1, 3, negative 16, and here we go 1, 3, negative 16. Can you see it? So it will give you in one go the result of the division, including the remainder. So that means that then you can say, therefore, P of x is going to be equal to the divisor, which was x plus 2, okay, multiplied by the quotient, which is the result. So, and also you're going to look at the original polynomial was a cubic one. So that means that it will be reduced to x squared. Right, so that means that this is going to be 1x squared, or just x squared, and then plus 3x, and then minus 16. Again, then plus the remainder. All right? You can divide any polynomial like this by a linear polynomial like this using the syntactic division. Okay, and it's really good. You can do the same process that it takes probably, let's say, in here it will take, just to say something, 5 minutes. In here it will take you not even 1 minute. All right? Okay. Let's continue. All right, so the next one. So the next one is x to the power 4 minus 2x cubed plus 5x plus 2, and we're going to divide that by x minus 2. And we're going to do exactly the same. So we're going to double check the answer, and then we're going to do the synthetic division just to check again, and just to practice a little bit more the new method. All right, so for the second one, so I'm going to say let P of x equal to x to the power 4 minus 2x cubed plus 5x, and then plus 2. All right, and the theorem says that if you want to find the remainder, all you have to do is evaluate the polynomial at positive 2 in this case. Okay, and then, well, we're going to do 2 to the power 4 minus 2 cubed plus 5 times 2, and then plus 2. Okay, and then you're going to tell me what is the answer for that one.
I don't know, I just made that up, but yeah, I think so.
What is it?
12.
12.
I'm not sure. I'm probably wrong.
It is 12.
Yeah. I didn't guess any of it, but it's a Monday, okay.
Right. Okay, so using the theorem, the answer is 12. Now we're going to double check. We're going to do the long division. So also, okay, and then you can see that there is a missing term in here. Can you see that the x squared is missing? Mm-hmm. Okay, so we need to be careful. So we're going to put x to the power 4 minus 2x cubed plus 0x squared plus 5x, and then plus 2. And we're going to divide that by x minus 2. Right. Okay. So we need to multiply x by x cubed to get x to the power of 4. So we're going to put x cubed here on top. And then we'll do the multiplication. So we're going to have x to the power of 4 minus 2x cubed. Right? And then you can see that this will give you 0, and the other one will also give you 0. We don't need to put the first one, but you need to put the second one. So we're going to have 0x cubed. All right? Make sure that you write that down. Okay, sometimes we skip that step, but it's better if you just do everything. Okay, and then we're going to bring the next one down. So the next one down is 0x squared. All right? And then, obviously, in here we need to multiply by 0x squared. Okay, and then we're going to just do the multiplication. So we're going to have x cubed, and in here we're going to have 0x squared. Okay, and then we're going to do the same. And you can see that in here we're going to have 0x squared. And we're going to bring the next term down. And we're going to keep repeating the same process. Okay, so we need to do 0x. Okay, that will give you 0x squared and plus 0 x. All right? Okay, and then we're going to do the subtraction. So we're going to have 5x in here. And then we're going to bring the next term, the constant term down. So it's going to be plus 2. And then we know that we have to multiply by 5. That will give you 5x and negative 10. Okay, and the answer is going to be 12, as we were expecting. Okay, so you can see 12 using the theorem and 12 using, the long division. Okay, when you do the long division, you've got to be careful, especially when there are some term missing, because you're going to have 0 like this, and if you put the wrong 0 in the wrong place, then you're going to get confused. Okay, so you've got to be very, very careful. Okay, let's see what happened with the synthetic division. How it works for that one. Okay, so when doing the synthetic division, we're going to put all the coefficients, including the missing one. All right? So we're going to do 1, minus 2, 0, 5, and 2. Okay, so you have to put also the missing one. Okay, and then in here you're going to put the opposite to that number, so it's going to be 2. All right? And then we're going to draw a line here and bring the first coefficient down. Okay, and then we're going to do, 2 times 1 is 2. And if you operate these two, then the answer is going to be 0. And 2 times 0 is 0. Then we're going to have another 0 in here. Can you see that we are getting exactly this number? Okay. And then 2 times 0 is 0. And this is going to be 5. And then 2 times 5 is 10. And that is going to be 12. So you get exactly the same number. Okay, and then you say, you can, if you want, you can do the polynomial. So it's going to be x minus 2. Okay, so this is going to be of degree, this is going to be of degree 3. Okay, so it's going to be x cubed. And then the square and the x is missing. Can you see it? Okay, so that means it's going to be only the plus 5. All right, which is the same as if you look at that line in here. Okay, and then plus the remainder. Well, you don't need to put that in here. All right, but that's how it works. Okay, so that means that you have three different way when finding, the remainder. So you can do it like this, you can do it like this, or you can do it like that. Now, in the test, if it doesn't say the way you're going to do it, you can choose the one that you want. But if in the test I want you to do long division, then you have to do long division. Okay? And if I want you to apply the remainder theorem, then you have to do it this way. Okay? But if I leave it open, then you can use also the synthetic division. All right? Okay. So that is good. Okay, let's do few more questions, and then we need to go to the factor theorem. All right. So this question 4, I think it is. No, question 3, yeah. Yeah, because it was question 2 part I and part B. Yeah. Okay, question 3 now. All right, part A. What is the remainder? What is the remainder when fx is equal to x cubed minus 2x squared minus x plus 2